In this video lecture, we'll talk about the thermal diffusivity. As I already told you guys, we'll talk about the thermal diffusivity in next lecture, in coming lecture. We'll talk about the what is rho Cp. We'll first start from the Cp. Okay, what is Cp? And then we will talk about the rho Cp, and then we will compare them, and then we'll come to the thermal diffusivity. Okay, guys. So okay, be patient. The product of rho Cp, which is frequently encountered in the heat transfer analysis, is called heat capacity of a material. Heat capacity of a material. Okay, guys. Both the specific heat Cp, this is the Cp is the specific heat capacity, and the heat capacity rho Cp represent the heat storage capability of a material. But Cp expresses it per unit mass. This Cp represent it in a per unit mass, as we already know that. Okay, guys, I assume that we know that what is Cp. Whereas rho Cp express it per unit volume. Okay, as it can be noticed from their unit. Unit is given. This is the unit of the Cp, that is joule per kg. This is the mass unit. Okay, per Kelvin, joule per kg Kelvin, and joule per meter cube Kelvin, respectively. Now let's come to the thermal diffusivity, guys. What is thermal diffusivity? It is represented by alpha. Another material property that appears in the transient heat conduction analysis is the thermal diffusivity. Okay, guys, diffusivity, which represent how heat diffuses through a material and is defined as alpha is equals to heat conduction divided by heat storage. This is K is, we know that K is heat conduction, and this is heat storage capability. It is its unit is meter square per second, guys. Now let me talk about the note, guys. What is the note? Note 1: a material that has a high thermal conductivity or low heat capacity. It means that if it has a high conductivity, high heat conduction, that is high thermal conductivity, and low storage heat capacity, then what will happen? Then a material that has high thermal conductivity K or a low heat capacity, that is rho Cp, will obviously have a large thermal diffusivity. Obviously, guys. Okay, the larger the diffusivity alpha, the faster the propagation of a heat into medium. Okay, the small amount of diffusivity means that the heat is mostly absorbed by the material. It is mostly absorbed by the material, and a small amount of heat is conducted further. Okay, it means that if the diffusivity is small, then it means that the material can store very high amount of energy. Okay, guys, it can absorb. Rho Cp is it means rho Cp will high. Okay, if the rho Cp is in the denominator power, so if it is high, then it will make the alpha will become less or small. Okay, it means that the material has a high capacity to hold or storage the temperature. Okay, guys, heat, not temperature, heat. Okay, guys.